Okay, so in this problem here, we're looking for the domain and the range of the inverse. So in order to do it, I'm going to look at the domain and the range of the original function. And so when I consider here, I know the domain of the original function goes from -6 all the way to positive infinity. I'm going to write it as in this kind of notation. It's actually, so -6 to positive infinity. I want to find the range of the original function. So I take my -6, I plug it in. 5 minus 1/3 times -6 ends up being 7. When I plug in 3, 5 minus 1/3 and 3, that ends up being 4. When I go to the second piece of the function, I plug in the 3, I get -2 times 3 plus 10 is also equal to 4. And if I pick some large positive value, let's say like x equal to 100, I get a sense, I know this is a line, so it's going to be getting more and more negative because that's 190. So the range actually is going to go from -infinity all the way up to 7. And so now here's the cool thing about original functions and inverses. The x and y switch, but also the domains and ranges switch. So the range of the original function is the domain of the inverse. And the domain of the original is the range of the inverse. And so if I take that negative, so I could also write that as x is less than or equal to 7 is what this says. And this one here says y is bigger than or equal to -6.